Hey guys, welcome to Innovative Learning. This is Professor Manish Narayan, and today we will be going over falling objects. This is part of the physics kinematics section. So let's try to solve a problem. All right, here we go. So let's assume that here's the ground, and we have some human. All right, throwing an object. So let's say they're throwing an object straight from the ground. All right, so there's an object, and they're throwing it upwards, let's say at 20 meters per second. All right, so we have a couple of questions we can answer with this. Part A, question is how high can the object go, right? How high object goes. Okay, so in order to solve this, we look at our equations of kinematics, right? Equations of constant acceleration motion. So we have V final equals V initial plus acceleration times time. All right, and then we have V final squared equals V initial squared minus plus 2 times acceleration times time. All right, and then so out of these equations, what are we given? So if the person throws the object with initial velocity, right? So remember, they give you the initial velocity, so that's V naught, okay, or V initial, okay, and that's equal to positive, right? 20 meters per second, okay. So what do I mean by positive? So whenever you solve a physics problem, you should always set up your coordinate system, right? So we have the upwards direction. We'll note that as positive direction, positive y direction. And anything going to the right, that's going to be the positive x direction. All right, so we have kind of an xy coordinate system set up. Okay, so they give us V initial equals 20 meters per second. Now think about it. If they throw it straight up, if you throw an object straight up, what happens? Well, it reaches a maximum height. It comes to a stop, okay, at this point. It comes to a stop, and then it comes back down. Okay, now what are all the forces acting on that object? Let's assume we're not taking air resistance into account. The only force acting on the object is gravity, and that's in the downward direction. And that's an acceleration due to gravity. It's called g. And since it's pointed downwards in our coordinate system, that's negative 9.8 meters per second squared. Okay, so gravity is pointed downwards. When we throw an object up, it comes to a stop. You see, so when you throw an object up, it comes to a stop. So that means that at this point, the V final, the final velocity, is equal to 0 meters per second, meaning it comes to a stop and then it falls back down. So what are all the pieces of information that are given in this problem? Well, we know V initial is 20 meters per second. All right. When it reaches the top, we know that V final is 0 meters per second. And we know gravity is negative 9.8 meters per second squared. That's the acceleration due to gravity. Now, out of our equations of motion, what do we have and what's unknown? So we're trying to figure out how high the object goes. So we're looking for D, the displacement. Okay. We know V final, that's good. So we know V initial. And we know acceleration due to gravity. So it looks like in this equation that should be a D. So we're after the distance. So we can use this equation. So let's plug in our variables and then solve for displacement in this second equation. All right, so V final, we know that's 0. So 0 squared equals V initial, which is 20 squared, plus 2 times acceleration due to gravity, which is negative 9.8, times d. All right, d is also known as delta x, okay, and that's the displacement. All right, displacement. All right, let's go ahead and solve for the displacement, meaning how high, when you throw something at 20 meters per second, how high does it reach? So we got 0 equals 400 minus, that's 19.6 D. So that means D equals 400 divided by 19.6. Okay. So I'm going to go ahead and punch that in the calculator. So let's pull up the calculator. There we go. So we got 400 divided by 19.6. All right, it's roughly 20.4. So we have 20.4. And remember, make sure you understand what the units are of your final answer. Otherwise, you get partial credit, right? So displacement is in meters, so 20.4 meters. All right, so this is how you figure out how high an object goes when you throw it up from the ground. Okay. Thanks for watching. We'll solve another similar problem in the next video. Please make sure to subscribe and give me a thumbs up. And hope you have fun with physics. Bye, guys.